Hi, this is Math 18, Section 2.2. Make sure I have my pen. So today we're going to look at simplifying variable expressions using the properties of addition. So we will also be looking at those properties that we'll be using to help us simplify these expressions. So like terms, if we're talking about a variable expression, those are the terms with the exact same variable part. So since x squared is x times x, and x is just plain old x squared and x are not like terms. So they have to be the same variable with the same exponent. That's the whole idea of like terms, okay? So if you look at the expression below, 3x plus 4 minus 7x plus 9 minus x squared. We have two sets of like terms. The 3x and the negative 7x are like terms, and the 4 and the 9, since those are just two constants, those are also considered like terms. So what we're going to be doing is combining the coefficients of the like terms together. So if you have, say, 2x plus 3x, you just add the 2 and the 3, which is 5, and you attach the variable on at the end and it stays the same. It doesn't change at all. So that whole process is called combining like terms. And to combine like terms, we're going to use what's called the distributive property. So the distributive property allows you to take a term on the outside, in this case a, times the sum of b plus c, and you can multiply the a times the two terms in the parentheses, a times b and a plus a times c. And same thing if the a is on the right side of the parentheses, you can still distribute that way also, and it just goes to the same two terms on the inside. So it lets the term outside the parentheses be multiplied by every term inside the parentheses. So look at these examples. We have 2 times 3 plus 4. Now normally you would just follow your order of operations and do what's in the parentheses. 3 plus 4 is 7. 2 times 7 would be 14. But the reason we have the distributive property is that sometimes you will be dealing with variables, and since you can't add, say, x plus 3 or x plus y, you have to use a distributive property to simplify that expression. So that would allow you to say 2 times 3 plus 2 times 4, which is what we did on the right hand side. Then 2 times 3 is 6, 2 times 4 is 8, and 6 plus 8 gives you 14. So you got the same answer either way. Same thing with the second example. Here we have 4 plus 5 times 2. The 2's on the outside of the right side of the parentheses. So we still distribute. We multiply 2 times 4, 2 times 5, and we get 8 plus 10, which gives you 18. Or if you added first and got 9 times 2, you still get the same answer. So basically the distributive property eliminates parentheses. That is the whole idea of the distributive property. Now another property of addition that will help you with simplifying your variable expressions is the associative property of addition. This property deals with keeping the order the same but moving the parentheses. Look at the example of the associative property. A plus b in parentheses plus c is equal to a plus in parentheses b plus c. So look at the order on both sides of the equal sign. A, B, C, A, B, C. It's the same on both sides. The only thing that has moved and changed are the parentheses. So what you want to remember is with the associative property, the order is the same and the parentheses move. That is what happens in your associative property. And you can see that in these examples below. 5 plus 7 in parentheses plus 15 should be equal to 5 plus in parentheses 7 plus 15. So if we add our parentheses first, 5 plus 7 is 12. 12 and 15 is 27. And on the right side, bring down the 5. 7 plus 15 is 22. And when we add there, we get the same thing, 27. So the second example shows you how it works with variable terms. 3x plus 5x is 8x, plus 9x is 17x. Or if we move the parentheses to the right but still kept the same order, we would do 5 plus 9x, 5x plus 9x is 14x plus 3x still gives you 17x. So remember, with the associative property, it's looking at the grouping, at how the parentheses are grouping the numbers, but the order isn't the same on both sides of the equal sign. Now, the commutative property of addition is where the order flips. Look at what it says here. If a and b are real numbers, then a plus b is equal to b plus a. So the whole thing here is the order flips. That's what happens with the commutative property. So 15 plus negative 28 is the same thing as negative 28 plus 15. The order that you add two terms in does not matter. 2x plus negative 4x is the same thing as negative 4x plus 2x. Either way, get the same answer. Now, two other properties are the first one is the addition property of 0, which basically says if you have any number and you add 0 to it, you still get that same number. Or if you have 0 plus some number, you still get the same number. So when you add a term and 0, you still get the same term. So remember, sum is addition, okay? So you're just adding 0 and you still get the same term. The inverse property of addition deals with opposites, okay? So basically, if you have any term plus its opposite, you always get 0, okay? So 8 plus negative 8 gives us 0, or negative 8 plus 8 is also 0. Same thing with negative 7x and positive 7x. That gives you 0. So the whole idea of the inverse property of addition, what I want you to see when you're looking at an example like this, 8 plus negative 8, is think, those are opposites. Another word for opposite is inverse. And that's how you'll remember that property, okay? So now we're going to look at actually using these properties to simplify some expressions. So basically, when you simplify variable expressions, you are combining like terms. So you find the terms that have the same variables, and then you add or subtract the numbers, the numerical coefficients. Add or subtract the coefficients. So look at number 1. We have 6x plus 8x. Those are like terms, so we add the 6 and the 8, and we get 14x, and the x just comes down with our answer. Now, number 2, we have 7a minus 5b plus 7a. You have two terms that have a's in them, okay? So you're going to add those. 7a plus 7a, so you keep that sign with the second 7, okay? Plus 7a would be 14a. Now, there's no other b terms, so you just bring down minus 5b. And then you look and you see, okay, are those like terms? No. So that's your answer. So some of your answers are going to look kind of weird because it may not come out to be just a single term. It may be 2 terms or 3 terms or more, but you only combine the terms that are like terms, same variable part. Look at number 3. This is where you really want to start working towards keeping the sign with the number behind it. We have 3y minus 10y. So what you're looking at, they both have y's, so those are like terms. Here's how I want you to see this problem. That is a positive 3. That is a negative 7. Negative 10. I gave you the answer. Sorry about that. Negative 10. So even though there's not a plus sign in that problem, you're using your addition rules. You have positive 3 and negative 10. So the signs are different. The rule is you subtract, keep the sign of the larger number. So that would be negative 7y. Okay? Now, when you're because we're only in the second section of chapter 2, if you right now still feel more comfortable of doing keep, change, opposite and getting negative 10y there, 3y plus negative 10y, and then it's easier for you to see negative 7y. For right now, that's okay to keep changing the signs, but you want to work towards not changing the subtraction signs and just taking it with the number behind it. It's going to make your life a lot easier, okay? So either way is fine. Let's look at number 4. We have 2x plus negative 6y minus 5x plus 3x. So we've got some x terms here that are the same. Okay, now some people like to rewrite it so that they're all grouped next to each other, and you can do that. Let's go ahead and do that. We've got 2x, and then I have negative 5x. You have to bring that sign down with that 5. Bring down the plus for the 3x, and then plus negative 6y. Okay, and the only reason I kept it in parentheses was because they started it that way. We're probably going to take it out of parentheses in a few minutes. All right, so look at our x's. We have 2x and negative 5x. 2 and negative 5 we subtract, keep the sign of the larger number, would be negative 3x plus 3x plus negative 6y. So let's go back over that subtraction again. Positive 2 and negative 5, you subtract and keep the sign of the bigger number, which would be the 5, so it's a negative 3x. Now, look at what we have here with the x's. Negative 3x plus 3x. Well, negative 3 plus 3 is 0. So your x's are completely gone because you have 0x. Well, 0 times x is still 0. So if you write an x in your answer, it's wrong. It's completely gone, so there are no x's, and you just have negative 6y is your final answer. Number 5. Let's draw a line here so we can see what we're doing. We have negative 3a squared plus 4b minus 2a squared minus 8b. So we've got some a squared terms, and we have some b's here that are the same. So look at your signs. Negative 3a squared, negative 2a squared. I'm just writing them so that they're side by side. And that is a positive 4b. Make sure you bring that sign down. And a negative 8b. Okay? So now look at your signs. You have negative 3 and negative 2. The signs are the same, so I add and keep the sign, which would be negative 5a squared. Okay? Then on my b's, I have positive 4, so you cannot just bring down a plus sign. You have to figure out the sign of your answer first before, and that tells you what sign to put between your terms. So positive 4 and negative 8, you subtract and keep the larger sign, which would be negative 4b. Notice when I say negative, I write a minus sign. If I say positive, I write a plus sign. There's only 2 choices, which is a good thing. So you got a 50-50 chance of getting it right. Hopefully you have good odds at that. But so that's what you need to do, is figure out the sign of your answer first, do the operation, and that'll tell you what sign to put in between those terms. Okay? And now you can't combine a squared and b, so that is your final answer right there. Okay? All right, so here's a couple more. Number 6 is 3x plus 4y minus 10x plus 7y. So let's see, I've got some x terms right there and some y terms right there, so we can kind of see the different ones. So I'm going to regroup them. I'm going to have 3x and then negative 10x. That sign comes down with the 10. Go back and pick up positive 4y and positive 7y. So now, 3 and negative 10, I have to subtract, keep the sign of the larger number, would be negative 7x. Okay? So that all goes back to chapter 1. That's what makes it so hard, is if you're still struggling with your sign rules, this is, getting pretty rough. So make sure you review those sign rules daily. Now look at the y's. I have 4, positive 4, and positive 7. That gives me a positive, so I write a plus sign, 11y, because I just add and keep the sign. Now, x and y are different, so that's my answer. Negative 7x plus 11y. All right, number 7. X squared minus 7 plus 4x squared minus 16. So I have like terms here with the x squared terms, and I've got 2 constants that I can combine together. So remember, what's the coefficient in front of that x squared? If nothing's written, it's understood to be a 1. So don't forget that. So 1x squared, and then we have a positive 4x squared, and then a negative 7, that sign comes with that 7, and a negative 16. Okay? So the first part's not too bad. 1x squared plus 4x squared would be 5x squared. Now look at the two constants. Negative 7, sign goes with the 7, and negative 16. The signs are the same. So the rule is add and keep the sign. So that would be negative 23. So we end up with 5x squared minus 23. Okay, so here's some for you to try. So pause the video and try these on your own. Number 1, 9x plus 12x. Those are like terms, so we combine the coefficients, which would be 21x. Okay? Number 2, 2ab minus 6ab. Those are like terms, so look at your signs. 2 and negative 6, we have to subtract and keep the sign of the larger number, would be negative 4ab. Okay? Number 3, 7x plus negative 6y minus 9x minus 2y. Let's see, I've got some x's that are the same and some y terms. Okay, so I'm going to rewrite them so that they're next to each other. 7x, and then we have minus 9x, and I'm just going to keep the signs the same here, plus negative 6y minus 2y. Just keep it the same way it's written. So look at your x's, 7 and negative 9. The signs are different, so subtract and keep the sign of the bigger number, would be negative 2x. The variable part stays the same. Look at your y terms, negative 6 and negative 2. The signs are the same, so add and keep the sign, which would be a negative 8y. Now, you have x and y. Those are different, so we're done. Negative 2x minus 8y. All right, let's look at number 4. We have 4x squared minus 3x plus 5x squared plus 9x. So we have x squared terms, and we have just plain old regular x terms. Okay? So if I have 4x squared, I'm going to bring down plus 5x squared, and then negative 3x, bring that sign down with the 3, plus 9x. Okay? So the two x squared terms are both positive, so I add and get 9x squared. Okay? Do not just bring down that minus sign, because you have negative 3 plus 9. Keep the sign of the bigger number and subtract. That's going to be a positive 6x. And that's it, because x squared and x are not like terms. Okay? And number 5, 5 plus 3y minus 7 plus 9y. So we've got some constants here and some variable terms there, 3y and 9y. So if I have 5 minus 7, I'm bringing down that 7, plus 3y plus, 9y. That's not a very good looking 9y, okay? So I'm going to do the subtraction here. 5 and negative 7, I subtract and keep the bigger sign, would be negative 2, and 3y plus 9y gives me 12y. Now, it should be noted that on any of these problems, if you flip the order of your terms, it doesn't matter. Like, I could also put the answer as 12y minus 2. You just have to be careful that if you do that, that you keep the signs the same on those terms, that you don't change the signs. So be careful about that, okay, if you decide to change the order on your problem. But your homework and quiz, it should accept the answer in either order. That should be fine. And that should be it for 2.2.